So we're asked to look at a little more complicated question using the product rule. And so we have 3x squared plus 5 to the power of 3 times the square root of x. And once again, step one, you want to identify your u and v functions. And so u, we have 3x squared plus 5 to the third power, and v is just the square root of x. And the derivative of u over x. What makes this a bit more complicated is the fact that you should recognize this will require the chain rule, what we just talked about. So we have to think about this as we have an m and an n, and so when I work out, the m is what is inside the function, and n is the bigger function. So I have the derivative of m with respect to x, and that is 6x, derivative of 3x squared plus 5, and the derivative of n with respect to m is just 3m squared. Go ahead and take rid of that. And so then, thinking of our product rule, we are meant to multiply 3m squared times 6x to get 18x. M squared, but I replace my m with 3x squared plus 5 squared. Okay? So there's my derivative of u. 18x times 3x squared plus 5 squared. And then my derivative of v, x, we've done a few of these before. It is 1 over 2 the square root of x. So now I'm ready to take my 4 parts and plug it back into our product rule. So leave the first, 3x squared plus 5 to the third times the derivative of the second, 1 over 2 times the square root of x. Add that, and now life becomes a bit more complicated. The square root of x times 18x, 3x squared plus 5 squared. Simplifying this a bit more, we have 3x squared plus 5 to the third over 2 square root of x plus 18x square root of x times 3x squared plus 5 squared. And for this question in particular, we would be happy having that as our derivative. It doesn't look very pretty. We could take it a step further. We have the 3x squared plus 5 as a common factor. I could write it outside. And so we just have 3x squared plus 5 over 2 times the square root of x plus 18x square root of x, and just make that look a little cleaner. Essentially, there's a little bit more simplified version of the same derivative. And as was asked in class, would you go farther with this, apply it? And yes, you would. This is a function, as a graph. I can ask what is the gradient of the graph at a certain point, or what's the slope of the graph at a certain point. And so if I want to know the slope at x equal 5, I would then come down to here and plug in x equal 5 and work that out. This is a more complicated derivative, then you'll most likely be asked on an exam.